Let's delve into JavaScript object accessors. This is a comprehensive guide that will cover getters, setters, and some advanced accessor patterns. Here is a quick code preview that shows the basic implementation of accessors using the get and set keywords. Getters and setters are special methods that control access to object properties. Getters are used to retrieve a value and setters are used to modify a value. Let's start with getters. Getters are special methods that allow you to access object properties while executing code. They provide a way to compute values dynamically whenever a property is accessed. For example, in this code, the area property is calculated dynamically using a getter. Moving on to setters. Setters allow you to execute code whenever a property is modified. They enable validation, transformation, and side effects when setting property values. Here, the setter for the name property will throw an error if the given name is less than 3 characters. The object.define property method is a powerful way to define accessor properties with detailed configuration. This method allows fine-grained control over property behavior and attributes. Here is an example of using object.define property. In this example, a getter and setter are defined for the price property using the object.define property method. Now let's look at some property descriptor options. These options provide more control over how a property behaves. Here we define a getter and setter for an email property. Also, we set the enumerable property to true, which makes it visible in loops, and configurable to false, which prevents it from being deleted. Accessors are very useful for implementing robust validation logic. Setters can be used to ensure data integrity and maintain business rules. Let us see how. First, we'll look at type and range validation. In this example, a setter is defined for the price property to validate the type and range of the value. If the value is not a number, a type error will be thrown. And if it is less than 0, a range error will be thrown. Next, we have format and pattern validation. Here, a setter is defined for the email property to validate the format of the value using a regular expression. If the value does not match the format, an error will be thrown. Computed properties are dynamic properties that calculate their values on demand and react to changes in the object state. Let's explore some examples. First, let's see how to create computed values. In this example, area and perimeter properties are computed using getters based on width and height properties. This way, every time the area or perimeter is accessed, a calculation will be performed and the result will be returned. Now let's see how dynamic property names can be implemented using accessors. Here, a define accessor method is added to the datastore class to define dynamic accessors for a property name given to it. These accessors will trigger update notifications when any value is changed. Accessors can help implement private data and control how object properties are accessed. Let's see how. First, we will see the private data pattern. In this example, the balance is kept private inside the bank account class using closures, and can only be accessed by using the getter method getBalance or modified using the deposit method. Next, we will look at the protected access pattern. Here, the secure document class uses accessors to log who accessed the data and when, making it protected. The content can only be accessed via the getter method, which also updates the access log. Accessors can be used with inheritance to create reusable patterns and extend functionality. Let's understand this with examples. Here we have a base class called vehicle which has a speed property with getter and setter. These accessors are inherited by the child class. The base class also has an isRunning property which controls if the speed can be set or not. Now we will extend this base class with a car class, overriding the base speed property. This shows how inherited accessors can be customized. The child class also has fuel level as a new property with the getter method to access it. Let's look at some of the best practices for creating efficient accessors. First, let's look at some recommended patterns. In this example, the full name is constructed only once, then it is cached using a map. So every time the full name property is accessed, the cached value is returned. This is called memoization. This reduces the need to compute values every single time. Next, let's see how performance optimization can be achieved using accessors. In this code, a define accessor method is created that takes in a transformation function. This transformation function is then used by the getter and a validate function by the setter. The setter also invalidates the cache if any value is changed. Let's explore some real-world use cases for accessors in common application scenarios. First, let's look at form data management. In this example, a form data class is created with a few properties and methods, including isValid, isDirty, and a setter for the email. The setter also validates the email and sets error messages if any. Now, let's look at a financial calculations example. Here, an investment class is created with principal, rate, and years properties. The future value and monthly interest are calculated based on these properties. And the rate property also has a setter for validation. Let's review the key concepts and best practices for JavaScript object accessors. Here are some of the best practices. Use getters for computed properties and derived data. Implement setters for validation and data transformation. Keep accessor logic simple and focused. Cache expensive computations. Here is an example of a getter that computes the total price. Now let's look at some common use cases. Accessors are generally used for data validation and transformation. They are used for creating computed properties. They are used for access control and encapsulation. And also for state management. Here, the setter validates the username value and throws an error if the username is less than 3 characters. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.